Okay, I don't know what happened there. So this is going to be in 2 videos. Sorry. So let's go back to the rules. What did the rules say? That if your top, okay, so remember there was 3 tests we talked about. Test 1, test 2, test 3. So if your top degree, I'm just going to say top and bottom. Maybe that'll be easier for you to remember, right? Okay, so if the top is greater than the bottom, the degrees, you know that, the degrees. The top degree is greater than the bottom degree, then there is no horizontal asymptote. Okay? If the top is less than the bottom, then the asymptote is y equals 0. And if the top is equal to the bottom, then remember we take the coefficients, you know, the leading coefficient. So we take the top leading coefficient over the bottom leading coefficient. Okay, so in this case, my degree on top is smaller than my degree on bottom, so my horizontal asymptote is y equals 0. And remember that asymptote y equals 0, that is the x-axis. Okay, so that is the x-axis right there when y is equal to 0. Okay, so that's 32. Which one am I on now? 33. Okay, and I already did 33. And I think I did 34 in class. 33, 34. I think I did 35. And 36. And 37. Okay, so for 33, it said find the accumulated value of an investment of $1,000. So P is 1,000 at 6%. So R is 6%, compounded semi-annually. So N is 2, and for 9 years. So T is 9. So your formula was A equals P parentheses 1 plus R over N raised to the NT. I'll go ahead and sub those in. So A, that's what you're looking for. It says find the accumulated value. Find A. So 1,000 times 1 plus 0.06 over 2. And then this will be 2 times 9. So on my calculator, okay, I'll be able to put all that stuff in on my calculator just like I see it. So I'll do 1,000 parentheses 1 plus numerator denominator fraction button, that one right there, 0.06, and then over 2, bump out, close your parentheses, use your caret, your raise up button, and then 2 times 9, or you can do 2 parentheses 9, it doesn't matter. So this would be equal to the accumulated value, 1702.43, because it's money, so you need to go to the hundredths place. Okay, so that is number 33. Number 33. Okay, number 34. It says find the accumulated amount, so I'm looking for A again. See what it gives me. Investment of 7,000. So my P is 7,000. 7%. So my rate is 7%. And then compounded continuously. Okay, that's a clue, right? I'm thinking E. And then for how long? 6 years. So my second formula I can use is A equals P times E to the RT. So for that one, I'll plug my values in. So A equals 7,000 times E raised to the 0.07 times 6. And so on my calculator, will punch those in. So 7,000 parentheses E. That's right there. You have to press the second function to get to it. It's above the natural log. 0.07 times 6. Bump out. I'm going to close my parentheses. I put parentheses to there to denote multiplication. You didn't have to put the parentheses. You could have put a times. But this calculator knows that parentheses means that you have to multiply. Okay, so I got my accumulated amount, and it is $10,653.73, and that is number 34. Okay. Next, number 35. Larry has $2,600 to invest, so that is my principal again. And needs 3,000 in 11 years. So that 3,000, that's my A. Okay. And he needs it in 11 years. And we want to know the rate to accomplish his goal if the interest is compounded continuously. So that's telling me that I'm going to use the E, right? So my formula is the A equals PE to the RT. But this time I have an A. So I would plug my values in. So it'll be 3,000 equals 2,600 E, excuse me, to the 11T, because it would be, 11R, because it would be 11 times R, and that's what we're looking for is the R, remember? So I'll divide both sides by 2,600. Okay, so calculator, it's going to be, I got 1.153846154 equals E to the 11R. Okay, so sorry. So our next step for this one, we know that we're going to take the natural log of both sides, and I'm not going to round. And remember, when I take the natural log of the other side, I'll get this. So divide by 11. So this is what I'm going to put in my calculator. And I'm going to see, can I save that? I don't know. No, I don't think I can. Okay, I'm just going to have to punch it all back in. 1.153846154 divided by 11. And so I get R is equal to 0.0130. And I'm going to change that to a percent because rates are percent. So move your decimal point 2 places. So 1.3%. That's number 36. Okay, number 37. Exponential growth. Okay, it's the same problem. So this time though, they've given us our initial investment, which it's going to be $6,700. I mean, we know that because that's the P, right? And then we know what our rate is because our rate's up here, right? So our rate is 6.5%, right? But the question is time. So they want A to turn out to be 8,800 or 8,689. So we have 8,689 for A. So this is the same exact work that we just did, except this time we're looking for T instead of R. So divide by your 6,700. And I get 1.296865672. equals e to the 0.065t. Take the natural log of both sides. It's going to be divided by 0.065, and that's going to be your t. Okay, so for my time, I got 3.99, which is 4 years. So that is number 37. 37. And that's what my calculator looks like right there. I just put that natural log divided by 0.06. Okay, next. 38. Remember, what's the biggest thing that I told you guys about these when you're dealing with the logarithms? Is that if you see something that can be written exponentially, write it exponentially. 36, he's screaming at me because he's 6 squared. Write it like that. So this is log base 6 of 6 squared is equal to x. My goodness, I did the same thing I did in class. I'm trying to solve it. So the answer is x is equal to 2. But they just wanted us to rewrite it. I'm sorry. Using the rules of logarithm. Remember, you take your base raised to your power, and it's equal to what you're taking the log of. So it's b to the c. I can't remember what the letters are. I just remember you go from your base to your equal to, and then that's what you have to make. So there you go. There's 38. 39. Where am I? Okay, 39. Trying to be quicker on this video. Okay, so 39. I have log base 3 of the square root of 3. Remember, when you can write exponentials, you write exponentials or exponents. Square root is the same as a power of 1/2. A power of 1/2. So you'd have a base to the 1/2. And your base is whatever's in here. Alright? So this is log base 3 of 3 to the 1/2. Then those are going to, y'all think of it as cancel out. They don't really cancel out, but. Okay, next. Oh, okay, expand. Log base 4 x plus 3 over x to the 4th. Remember, this is the quotient rule. Quotient rule says that those things were actually subtracted. So I write it out. I expand it. Okay, so now I have log base 4 of x plus 3 plus log base 4 of x to the 4th. And so then my next step is to go ahead and pull that exponent down. And that is number 40. And your answer choice for that one was, oh, this is supposed to be a subtract. I said subtract and I put an add. I'm sorry. Remember, quotient rule, you subtract. And so there's your answer. Log base 4 x plus 3 minus 4 log base 4 of x. Okay, 41. What am I doing? Condense. Okay, so 5 natural log x minus 8 minus 4 natural log x. Okay, I'll go ahead and do my power. So natural log x minus 8 to the 5th. Go ahead and do my power minus natural log x to the 4th. If it's subtract, that meant it was a quotient. And so x minus 8 to the 5th is on the top and x to the 4th is on the bottom. And that is answer choice C. Yeah. So that is your answer choice C. Okay, 41. That one was easy. But y'all, those have gotten pretty easy for you, I'm sure. Okay, next, number 42. 42. So, number 42, they want us to go ahead and solve this one. So number 42. Okay, so the equation was 4 raised to the 3x minus 5 is equal to 256. 256 can be written as a power of 4. You just got to figure out what the exponent is. Okay, so what you'll want to do, you can do it one of two ways. I mean, you could use the button right here. Let me clear that. If you can see above the, if you can see above the caret, there's a radical with a little x for the index. So you could try a few things, for that and see what happens. So you could do, I found it on the first try. So I did the 4th root of 256. So that means that 4 to the 3x minus 5 is equal to 4 to the 4th. So since the bases are the same, then we know that 3x minus 5 is equal to 4, and we solve. So let's add. So 3x equals 9, divide by 3, so x is equal to 3. Number 43 says to solve e to the x plus 2 is equal to 5. And so remember, on this one we'll take the natural log of both sides. So when we take the natural log of both sides, then on the left hand side we're just left with x plus 2. And so x plus 2 is equal to the natural log of 5. Subtract 2. So x is equal to the natural log of 5 minus 2. And you'll use your calculator because that one they want it in a decimal. So natural log 5 minus 2. Oh, excuse me, that's not right. Natural log 5, close up parentheses, minus 2. There we go, that's better. And so for that one, I get negative x is equal to negative 0.390. And so that would be negative 0.39. Okay, number 44. We want to solve and reject anything that can't be part of the domain. Okay, so that one kind of gave me a hint. There may be something part of the domain that I got to be careful about. So I have 3 natural log of 3x is equal to 12. And I think if you remember right, I told you guys that if you have just a constant on the right hand side on one of these, and then there's something multiplied out front, you need to go ahead and divide right there to get rid of that. You don't want to put that back in a power. Okay, so be careful about that. So I get natural log 3x is equal to 4. Natural log 3x is equal to 4. And so I know from one of my rules that this tells me that 3x is equal to e to the 4th. And so I would divide both sides by 3. So x is equal to e to the 4th divided by 3. So the only way that we can't use this is if when we plug this back in, it's going to give us a negative. And it's not going to, because this is positive, the 3 is positive. So when I multiply all that together, it's going to be positive. So this is a good answer. Okay, number 44. Okay, where am I now? 45. Okay, so for number 45, it says to give the domain, and it is log base 6 of x minus 3. Yes. Okay, so we know that we cannot have, this part can't be negative, right? So we know that this x minus 3 cannot be equal to 0. Or actually, I'm sorry, it cannot be less than 0 because it can't be negative. So add 3 to both sides, and so we get x cannot be less than 3. Okay, x cannot be less than 3. And this is number 45. So let's go through our answer choices. So x cannot be less than 3. So if you're thinking about a number line, 1, 2, 3, 4, 5, 6, that means that it has to go this way, right? And so that means from 3 to infinity. Cannot be less than or equal to 3. So that should be an open circle. Okay, so 3 to infinity. 46. Values. Okay, so this is a solve. So log base 4 of x plus 3 plus log base 4 of x minus 3 is equal to 2. So if we go through and we use our rules, we know that if we were adding two logs together, that meant that these two things were multiplied. Okay, so I know that that tells me I would have had log base 4 of x plus 3 times x minus 3, and that would be equal to 2. And so we know this is the product of a sum and a difference, and so that's log base 4, and this would be x squared minus 9 equal to 2. Okay, so using our properties of logs, we know that 4 raised to the second power has to equal x squared minus 9, and this is 16. So 16 is equal to x squared minus 9. Let's get it equal to 0 so we can solve it. And we'll see that we've got a difference of 2 squares. We have an x plus 5 and an x minus 5. Okay, so this factor would give me x equals negative 5, and this factor would give me x is equal to positive 5. And those would be okay, but we do have to double check them with the domain. So going back and looking at your domain, so let's see, coming up to my original up here at the top. Okay, so I've got this guy right here, and I've got this guy right here, right? But I know that this can't be negative, and then this can't be negative right here. We can't have negatives. So if I come back here, and let's talk about 5. If I plug 5 in right here, I'm good, because that's 8. And if I take 5 and I plug it in right here, I'm good, because that's 2. So 5 looks good, right? So try negative 5. If I plug negative 5 right here, I get a negative. If I plug negative 5 right here, I get a negative. So that one does not look good. So that ended up being an extraneous solution. So x equals 5 is the only thing that actually works for this problem, even though we got 2 answers. Okay. What number are we on now? 47. Okay, so 47, same type of problem. So we have log, and I'm going to write this as x plus 4. 4 plus x and x plus 4 is the same thing. Minus log x minus 4 equals log of 3. And so log of x plus 4 over x minus 4 is equal to log of 3. And so we know that if these two are equal, this is like log base 10, this is log base 10, right? So then that tells us that x plus 4 over x minus 4 has to be equal to 3. Otherwise, this whole thing wouldn't work out. So now we can solve. Put this over 1. Then I would multiply, because this is, I can cross multiply on these. So I multiply, and they should be equal. So 3 times x minus 4 should be equal to x plus 4. So 3x minus 12 should be equal to x plus 4. Subtract your x. So 2x minus 12 is equal to 4. Add your 12. So 2x is equal to 16. Divide by 2. So x is equal to 8. So come back up here and double check. Does 8 work? Is 8 okay here? Is 8 okay there? Looks like it's okay in both. So the answer for number 47 would be 8. Okay, if you don't understand this part, let me do this one more time, a different way so you see. So what we're saying here is if this is log base 10 and it's x plus 4 over x minus 4, and this is log base 10 and it's 3, then if these two are equal to each other, then what's here has to be equal to what's here. Okay, so that tells me x plus 4 over x minus 4 has to be equal to 3. So this is actually 3 over 1. Well, I got to get rid of this x minus 4 in the denominator. So if I multiply both sides times x minus 4, then those x minus 4's cancel out, and I get x plus 4 is equal to 3x minus 12, distributing, and then the steps are the same from there. I just wanted to show you in case you didn't understand the way I did it the first time. Okay. Where are we now? Okay, 48. I already did 48 in class. And I did 49, 48 and 49. I'm not going to redo those because I've already done those in class. And then number 50, that's, like I said in class the other day, that's a baby one. I mean, that's just a domain, right? Looking at that picture, you should be able to tell what the domain is. Oh, and the range. It wants the domain and the range. Just be careful on the range, because notice that, like, the lowest point, okay, the lowest point, let me zoom in. If you're talking about the range, which is up and down, so you're asking yourself to go from the lowest point on this graph to the highest point on this graph. Well, this graph is going to continuously go up, right? So the lowest point on this graph is -1, and it's going to continuously go up. So it is -1 to infinity. There's a solid dot right there. So that's why you have to use -1 to infinity. Okay, that's your range, right? Now, looking at your domain, okay, so domain is how's it going right and left, right? So what's your smallest value on your going right and left? Well, your smallest value is 0 because it's on the y-axis, so it's 0. And then it's going to go this way. So and it's a solid dot, so we need a bracket, so it would be 0 to infinity. So the answer would be B because it goes from 0 to infinity. Okay? Hope that helps, and tomorrow night we can Zoom.